that make this work that the research group is involved with is a first layer about connecting the data from the devices to the backend database. So that's what we call the programmable data router. It currently speaks BACnet and Fidget, and I think there's some other support in the works. And that allows us to connect to the devices and bring the data into our database. And the database itself is a historic time series database that's cloud hosted, and it has some processing of the data on ingestion that enables some of our visualizations. And then we have some research projects around analytics and machine learning for extracting more rich data through sensor fusion from the data sets. And then the client library is, for splash charts, is one of the charting features that ties back to the database. I can show you how that works. And then, of course, this front end, which I just showed you, which is Dasher itself.
Basically, I mean, the difference between our system and others probably is just that because we want these high quality visualizations where we can select, 1,000 sensors and some period on the timeline and hit play and have it interactively show all this data, we pre-compute a lot of these things so that they're ready to go, so that there's not a big query and a delay and so on. And so that's the sort of unique aspect of this stuff.
Okay.
This is just an example that's quickly showing here around how as you zoom into the data or as you pan through the data, you get a coarser view and then a more fine-grained view. This is from a research paper from a number of years back, but this function, this technology has been built into the charts that are used in Dasher. And because I can't make this full screen, these two were little GIFs that show similar behavior, just this quick pan and zoom functionality of the charts themselves.
We can see it fine. It's good.
Okay. This is quickly just an example of the kind of machine learning. We're doing some computer vision and skeletonization on the camera feeds from the bridge to create derivative data sets of occupancy and hopefully more fine-grained behavior in the future. And then I think quickly here, there's a continuation of the previous video, which just shows we've done processing on the video. And what you see on the timeline on the bottom here, these little blue ticks, these represent when there's an occupant or multiple occupants on the bridge. And here you're seeing it at night, and it's going to quickly jump across to the morning, so you don't have to spend, say, hours watching the video. That it only plays back when there's actually an event happening on the bridge. And then this is someone navigating through some of the data sets from one of the accelerometers. So yeah, there's a few examples of what's possible. This is a great project with NASA where they have a very nice fine-grained deployment of sensors for temperature and humidity in their buildings. So you get these rich visualizations of how the data changes over time. And another collaboration does a similar thing, but it layers on occupancy. So Schneider Electric was working in a partnership to develop an occupant sensor that does relative position to its location on the ceiling. So what you can see here is the counts and the positions of the occupants relative to those sensors. And you start to be able to extract an understanding of, say, the CO2 levels rising with high occupancy and so forth.
Maybe I can just add that there's this sort of hatched area where we don't have any sensor data because we didn't want to just interpolate across the whole thing implying that we knew what the data was there. And so we specifically try to call out areas where we don't have data as well, so that we're not, so that the visualizations are not misinterpreted to where the data is coming from. And so in the previous one, the NASA one, you can see that there was data everywhere. It's not that we were just interpolating over the whole thing, that actually they have very high density of data, which is really nice.
And this is our new office now in Toronto, so we're starting to look at instrumenting it in more detail. We've done a few quick tests. I don't know if these are as relevant to our discussion today about looking at the opportunity of collecting data from construction sites or in a manufacturing facility. We worked with a few different IoT vendors. Pillar Technology does environmental sensors that can be kind of temporarily mounted and then moved throughout a construction process. Triax is a worker monitoring system that can do zone-based tracking, so they know throughout the building what zone the workers are in, and then if they have any sort of incidents like a trip or a fall, it's able to detect that and send it back to the site foreman. They can also do an evacuation alert to get people to leave the site. So that was a worker tracking, and then we worked with Versatile Natures, who do sensors for crane loading and positioning, and these three came together. This is more of a demo. In terms of the 3 data sets were not specific to this building, but we were able to bring them together into the single context and build out an understanding of, in this case, it's a demo of what would happen if, say, there was a dust storm or some sort of event that triggered bad air quality on the site. You can see in a moment it'll go red, and then the workers who are represented as orange will evacuate the site. So just the idea that bringing many of these data streams together into the one context gives you a better, richer understanding of what's happening on a construction site.
Can I ask you a question?
Yeah, please do.
I mean, the one use case that jumps out at you here is like evacuation in a fire alarm.
Mm-hmm.
But obviously that means that everybody would have to have some form of detectable ID. So right now, how what kind of sensors are you using for the occupancy? I mean, that one looked like a fairly large kind of belt-worn thing. And I'm sure that would develop anyway, but have you considered that kind of use case?
We've had some conversations around occupancy simulation, or maybe like real-time occupancy rerouting with a researcher at the University of Toronto here locally. But in that case, it's not capturing a real-time picture of what's happening in the building. So I think the challenge around occupancy is accurate positioning of people. The work we're doing around that is primarily what you saw with the bridge project, where we're locating counts and kind of behavior of people as they move through the site. Maybe Alex, do you want to comment on that? I see now that
yeah. So occupancy has been a difficult thing to track for, I guess, 15 years for us now. And we actually have a separate project that's looking at occupancy tracking, and that's Project Ajna, that mostly uses computer vision-based techniques. But we've dabbled with radio frequency detectors, with mesh networks, through Zigbee, through Ethernet triangulation. But I'll be honest with you, I personally don't feel any of these technologies are reliable enough or precise enough to get the kind of occupancy that we're looking for, which is why we mostly turn to advanced computer vision techniques. That being said, there are a lot of different technologies available on the market, that some of which use hybrid techniques with a combination of RFIDs and emitters all over the place. You can sort of piece together badging information, computer vision information, choke points, and so on. But from what I can see, especially in a facility like a campus or like a building like ours, it's still very much an open area of research. But one thing that we do have all over our buildings is security cameras, which is why we're mostly turning to computer vision to fill that gap. Right now with Project Ajna, we're doing the skeletonization that Hallie may have shown earlier when I got cut off. And we're able to pinpoint you in the 3D scene within about 2 to 3 inches, which seems to be giving really good results right now, but it's still early days for that particular technique.
That does conflict with some of the probably some of the privacy things and all of that, which is the usual concern. But that's why actually Schneider Electric is experimenting with the sensors that Hallie showed earlier, with the green people coming and going there, is to have sort of a lowish resolution view of who is in the within the zone of the sensor, so that they can actually count and place where people are without being able to identify them.
Yeah.
And so probably something like that will be the ultimate winner in that kind of situation, where you can make sure that a place has been evacuated.
Yeah, they're using low resolution infrared cameras.
Yeah.
So just CCD devices. Yeah.
And overhead, so that there's no faces.
Yeah.
But don't forget the drones.
Right, drones.
The indoor drones.
Yeah.
But one of the things that is top of our mind in American universities is active shooter. And I'm just thinking that there's probably a good application there too. You know, if you see somebody moving around that doesn't have an ID, then, you know, there's ways to track people. And technically on our campus, at certain times anyway, we control who comes in and who leaves. So I think that's going to develop over time as well.
There was a system in a hospital where they had the badge, like the kind I'm wearing here, where they would detect when you enter a room that badge was coming into the room. So that was one system that a hospital had some good experience with. And
there's a lot of security companies out there that are good at this technology. So
Yeah.
you might want to look to one of them to partner too. So
yeah.
The issue for us in research is always cost.
Exactly, which is why you would need a corporate sponsor for the security system. And now, you know, with the active shooter thing being so big in America, I'd be surprised if you couldn't find somebody.
That's true. Well, luckily in Canada here, we
yeah,
we have less shooters in amongst us. So, but yeah. I assume Honeywell must be involved in that too. They make security systems as well, right?
Yeah, absolutely. Yeah, but we don't have Honeywell security here though. We have Lenel, which is really a shame because you know what we're doing with the our
Autodesk buildings are Lenel as well.
Yeah. Anyway, you know, just a thought for you, you know. And I meet with the Honeywell people fairly regularly, so you know, next time their R&D people come in, I'll certainly talk to them about what you're doing.
I mean, Honeywell's
doing big IoT consortium at USC, and you know, a lot of people like Honeywell are getting involved in that as well. You know, trying to decide what to do about that privacy issue. We can collect the data fairly easily, but what do you do with it once you collect it?
Yeah. Well, maybe if the skeletonization is being done at the camera, and only the skeleton is transmitted through, that would be one way of anonymization.
Yeah, so and certainly from the campus-wide perspective and what's going on around the campus during an active shooter type event, that would be really useful. Inside the buildings, it's more difficult, obviously, to get everything covered.
Yeah, that's why it always has to be a composite of technologies and not a single one at this point.
Hallie, do you have any of that stuff?
Yeah, I can switch to the campus one now.
Okay, great.
I might have to switch this twice. I just don't know if this slide deck has the most recent. Is that showing up there?
Yes.
Oops, wrong button. Try to make it bigger. So this was a project bringing kind of the operations department at Carleton University in Ottawa together with ourselves and some of the education groups studying building management. And we've always kind of talked about the Dasher system as starting first with the buildings, but the potential to scale up to the urban scale, kind of what we've just been speaking about, and then the campus is a good stepping stone towards that. This project, the Carleton campus in particular, is quite enclosed in that it has the canal, the river, and a highway that define its boundaries very clearly. So it's a good study site for understanding the kind of campus as a whole. And the 4 buildings you see highlighted here in red are ones that the students.
Oh, we're not seeing that. We're just still on the main slide on the PowerPoint view.
Yeah, I think you're sharing your it says carletoncampus.bbtx. And we see the whole slide deck, not in presenter view. So you might be sharing it on a secondary desktop or something.
Strange. Let's try that again. I moved it from one monitor to the other. That's probably why. Okay, so yeah, this was the first. Are you seeing that now?
I'm seeing the four green dots.
Yeah. Okay, so this was just what I meant about scaling up to the city, and then this slide shows the river, the canal, and this highway, and the 4 red buildings being the ones that they went into detail with building information models for, similarly, by the sounds of it, to what you've done with students at USC. And in this case, there were some laser scanning studies as well done for validation. and then the detailed BIMs, which what you see here is the rendered version versus the real photograph. So they were extremely accurate models that were built out of those 4 buildings, including the detailing of the facade and the construction. But one of the more interesting things was that they went through this study of trying to get data on energy and spending on energy from all of the different buildings on the campus, and then including the data on where that energy is coming from and which departments are responsible for that, for those particular sites. In this case, you should see a zoom in on annual spending, which is kind of interesting. So what they spend on grid electricity versus district water versus natural gas, and how that flows through to each of the buildings. These are statics.
Can I interrupt for a second?
Yeah.
I'm really intrigued on how you do the graphics for this. I mean, I'd love to be able to do that kind of graphic myself.
Yeah, I mean, it's actually a standard library called D3 that has a Sankey diagram option. The hard part is just really collecting the data. So if you want to go back, Holly, you can see in the center there of the previous one, total energy is $12.1 million. It's probably pretty easy to find out what your total budget is. But then how it breaks down into grid electricity, 7.6 million, district water, 1.7, natural gas, 2.8. And then further to the central heating plant and what the losses are from one of the other and things like that. This is a combination of some calculated things together with the actual data, and then some estimates as well. So there is an entire research paper on this that we can send you as well. And then they've further taken that further in within each building as well.
Yeah, I mean, we have the same kind of data that we have to capture. Like most universities, we have to capture our data by building, and we have to report our costs by building every year. So we have, it's a pain, but we do track it all. Well, less so water here, but
the next one is water.
Yeah, there's water. One of the things they modified the library for was to close the flows, as in you see in this annual mass flow, so that they can show the recycling in the system. So that's not natively supported by the library. Okay. And another thing to point out is you can do the scatter gather. So you can actually get a notion for losses in your metering. So when you go from left to right and you break it down into lower level aggregates, if you then regather those into different hierarchies, you'll actually see losses as well. And that's something else that isn't in these particular slides, how to show those losses and so on.
Exactly. Right.
I'm going to switch again to sorry to keep switching windows, but I switch again to another slide deck that has that updated demo on this project.
Our goal with that research is to have a real-time version of that. So that was annual, the Sankey diagram. So we'd actually like to have like a live version of that as well.
So would I.
Whoops. So this is a video showing a more recent development where we've started to connect that diagram to the 3D version of the campus. So it's kind of zooming from the building out to the higher level. The coloring corresponds to the Sankey diagram that you see that's visualized here, and you can start to interact with that data. As Azam said, this isn't something that we can play back over time. It's still using the same kind of aggregated annual data that was developed for those original snapshot visualizations, but the link between the 3D model of the campus and the plot.
One of the things for us though is when you overlay, if you have this historically over years, and you can overlay the actual historical temperature data, it allows you to predict your weather, your utility costs much more accurately. As you go through the year. So, and that's the challenge for us. Is obviously like any other university, we have to balance the zero, and trying to do that with utilities is virtually impossible.
Right.
And we can miss by quite a bit sometimes, which upsets the budget office. We're always on the upside, not the downside of this. We always give money back, so we're not the enemy yet. So.
Yeah, so here we've extended Dasher with so there's still the building view as we have before, but now that we have the campus overview, so when you select a building, if there is a building information model, it'll load in the right. As you can see, there's some hashed model, like hash shading on the the campus view as well. So those buildings don't have a detailed building information model. And then you can click on the Sankey diagram. You can click on the building in there too, and that'll load in the other windows as well. So it's a sort of a three-way sort of navigation between all the different things.
And these are all these graphics are all based on the original an actual model for the building.
Yeah, all the massing models came from the actual buildings, and then all of the BIMs are the actual BIMs on the campus.
Okay, because obviously the other thing that's impressive here is how fast it renders. So.
Yeah.
Yeah, and it's in a web browser too, so it's you know, it'll work on your phone or your iPad or
Not that fast though.
well,
but it will work.
Depends, yeah. Not that fast, not as fast as the drawing, but and the internet speed, of course. But the point is, you can take it with you in the field as well. So.
Yeah, just one thing to note is the model of the campus itself is actually coming from InfraWorks. So this is a view of the same model made in InfraWorks, and InfraWorks now hosts their 3D geometry on the same Autodesk BIM 360 platform and format that the Revit models are pushed to as well. So both of these kind of file formats, the 3D model from InfraWorks and the building models from Revit can become hosted in the same cloud platform, and that's why we're able to access both through this dashboard.
And is your GIS involved as well, or how do you locate the buildings with InfraWorks?
That's pretty easy. I mean, you just select a piece of the world. Like we could do USC campus as well. In half an hour, we'll have a 3D model of that. It won't be, you know, accurate, but it'll have the correct GIS and the massing models of the buildings. And then what we would love to do with you is exactly do that, but then link the detailed building information models to like show up on the right there, and then with the sensor values as well. That would be cool.
Yeah, and what's particularly interesting with InfraWorks is I don't know about USC campus, but most Canadian campuses have quite a vast underground network of tunnels for steam and gas and other kinds of things. And InfraWorks it's basically designed to model that kind of underground infrastructure. So you don't just see what's above ground, you see what's below ground.
So I don't have tunnels because we're a mild climate, so we don't have to bury everything. I would be interested in modeling the 3D underground, though. I mean, we've been talking about that for quite a while, and I think Civil 3D was the best we saw, and maybe that was kind of cumbersome. So. Yeah.
Yeah, InfraWorks does a much better job at that. Did you also mention our Esri partnership as well?
I mentioned it. I have a video of that, but
I think it might be later on in the slides here too. I'm not sure.
Is it the one that Kian made most recently?
Yeah.
I don't think it was in this deck, but I have a link from him, so I'll just stop again and find that quickly.
I mean, it's the same thing.
Interesting to us as well, though, because we have our geography department has a contract, I think, with Esri as well. Any collaboration that's going on with Esri, I'm interested in. So.
Okay, yeah, we can show that too then, if you want, Hallie, or I can share it too.
Well, we don't have to share it right now, but you know, I'm enjoying the presentation as much so far anyway. So I don't want to stop you from presenting what you have. So.
Yeah, Autodesk at large is partnering with Esri. We at Autodesk University, which is a big trade show in Las Vegas, just this past November, we declared that partnership, and so there's multiple initiatives going on, not just inside of research, but also with various product teams, and InfraWorks is working very closely with them to try to integrate that, I guess, globe level GIS data with the local data we have for that underground infrastructure in cities.
Right. Cool.
I'm just waiting for this video to load on the web. See if it comes through.
It basically looks the same. It just has, instead of our InfraWorks campus viewer in the corner, we have the city of New York and all the buildings there, massing model again, and it's showing in the Esri web viewer.
Wow.
Esri web viewer. Is it like City Engine?
Able to see that?
Yeah.
Yeah. So this now, instead of another Dasher or Autodesk Forge viewer window, is the Esri viewer window, but embedded into the same page and with the same connection between the Sankey data and some kind of just hardwired example buildings. So these aren't just for the demonstration purpose, but.
And that's with Esri's City Engine, right?
Okay,
I think, yeah.
Yeah. But it's a little mock-up, so we're using the same campus data from the Carleton campus, but just accessing it through the New York City model.
Yeah, so the idea is
So it's just a proof of concept.
these high-level viewers for course level of detail, but if you want to dig into, you know, rooms and individual unit parts of the building, then Dasher is still the tool. And so we're working on better integration between the two at the moment.
okay.
I think we can move on, Hallie, bigger slide.
The Esri viewer and then the Dasher viewer, what's like the relationship? Because in the Esri viewer, it seems like only the envelope or of the building, but in the Dasher, it seems like the whole Revit model.
Correct.
Is it like any data go across?
Any data go across?
Not yet.
Not really. You know, ultimately, that's what we want to do with the Sankey diagram, is have that, you know, that time series data of the aggregation of the buildings and the functions and the infrastructure of steam or water or hot water and so on, power. Also the city grid as well as a hierarchy. And everything there, of course, we want everything, but currently there's no data going between the levels.
Yeah, one thing with us is we basically have our own infrastructure, so you know, the only city connections are at the two vaults that enter the campus.
Yeah, that's why we like the whole campus model thing, is because you control everything.
Right. But one of the things that we're doing with this IoT consortium, though, the City of LA is involved with us, and basically what the logic is that we model a mini city like USC, and then it should scale to a city like LA.
Yeah,
Perfect.
that was our hope with Carleton as well.
Yeah. But the advantage, of course, with USC is that you guys are further along. We only have the 4 models for the Carleton campus, and the whole campus is a lot smaller. So we'd love to collaborate with you on a bigger version.
Okay. One question before I go, because I have to go in a couple of minutes here. You mentioned one of the universities, and it sounded like you mentioned research in facilities management, or maybe even a degree in facilities management. Was that the case, or did I just mishear that? Building management research at Carleton University?
We got permission. I mean, this was the nice thing about the Carleton, is that we got permission from the VP of facilities to have access to any of the data. And so that's...
Yeah, I misunderstood. I was hoping that they actually had within one of their schools, they had a facilities management with those kinds of technology training.
I may have just mentioned, I meant sort of the students who were studying more the building science side, or the coordinating the data connection to the Sankey.
But even at that, if with that kind of a background, you know, it's the kind of thing that you could consider recruiting, you know, when they finish their work. So.
Right. It's so Carleton, it's the Department of Civil Engineering and the Department of Architecture that we're mostly partner with, and it's in a special unified lab called the CIMS lab. And I don't remember what CIMS stands for. Do you recall, Azim?
Immersive media something.
Systems. Yeah, I don't recall.
I'm not sure, but it's probably the C is Carleton, Immersive Media Studio, something like that. But it's really the architecture students that build the building information models, and it's the building science people that are doing the Sankey diagram and the energy modeling and all of that.
Under the Department of Civil Engineering.
Well, we have one group in architecture that's doing something similar. So I might be able to put them in touch with Carlton as well, or actually bring them into whatever it is we end up trying to consider.
Great.
Okay, good.
Well, thanks so much for your time.
I enjoyed it. It's one of these presentations.